Okay. Yeah. So good morning, one and all present here for this webinar session. First of all, I invoke the blessings of Almighty to complete our webinar successfully today. And first and foremost, I would like accord my welcome to our speaker of the day, Engineer Naveen Aiathurai, Director of Engineering Searchblox. I, on behalf of Francis Xavier Engineering College, Department of Information Technology, and as a whole team of Department of IT, I accord my sincere welcome and to the speaker of the day who's here to share his insight, experience, and technical expertise to all of us. I welcome you, sir. And
Thank you, ma'am.
thank you, sir. And I would also like to welcome all the participants of the day who have been giving immense support for us throughout the webinar series. And thank you so much for your participation and being here for this webinar. And welcome you all once again. And let me give a short profile of the speaker today, Mr. Naveen Aiathurai, Director of Engineering Searchblox. He has completed B in Computer Science and Engineering, and he has started his career as web developer in Affinity Web Services, Chennai. And he has also developed bureaus which include search engine-based application development. He is also worked as a developer in Open Search Server, and he is also responsible for Open Search Server-based applications and plugins. He had added new features into it, and he has also been a lead development engineer in Searchblox, and adding new features to the Searchblox. And he's also working with open source projects like Manifold CF, Elasticsearch, etc. And now currently he's the director of engineering remote in Searchblox. He has 10 plus years of IT experience in software development with much more exposure and rich experience in search server domain. He has got extensive experience in Java, software architecture, search algorithms, and he's an expertise in build tools such as Ant, Maven, and Gradle, and his experience in Linux and Windows Server. So we have a technical expertise here today to share his expertise with us, sir. We are eagerly awaiting for your session for the day, and over to the speaker. We
Thank
shall
you.
start the session, sir. Thank you.
Sure. First of all, I thank you for giving me this opportunity, and I welcome everyone to this webinar. Let me press first. I hope everyone can see me screen, right?
Yes, sir. Yes, sir.
Cool. So, if first of all, if I'm not audible or if there is any network issues, so let me know. I can connect back or we'll see what we can do. I'll try to keep this webinar interactive. If I ask a question or if you have any questions, just put it in the chat box or you can speak. I can answer it quickly. So, okay, then let's get started. So, before we start, I'll give a small introduction about Searchblox, the company I work. Searchblox is an AI-driven enterprise search solution. We have around 150 data sources where we can apply search for it, and we use artificial intelligence on it to make search. Some of our major customers are WHO. We all know WHO today because of the COVID. So WHO, the HHS, which is Health and Human Service of US, and the US Senate, Nokia. We have a lot more customers. We will see how some of these customers are using our search and search AI in their applications in the later stage. So today, what we are going to see today in this webinar is how search engine works. Like what actually happens when you type a keyword in a search bar. The most basic thing of search, and then how AI is powering in search nowadays. What are the advanced AI things we use in search, and how it is used nowadays in the world. So the last thing is we are going to create a search engine for the college and see how it works. It's going to be a good demo to just get hands on to it. Any questions? Okay. So the first thing is, what is a search engine? Basically, a search engine is a software system that is designed to carry out web searches in the World Wide Web or in any applications. Basically, a search engine is a tool that helps us find information in a large set of data sets. Let's say you have a large data set. You need to find a small piece of information. You need a search, right? So that's the main. That's what search engine is. It helps you locate the information from a large pool of data. So where are the search engine used nowadays? Nowadays there is no one is creating application without search, right? So why we are using search engines? Why there is a need for search engines? Because we became very lazy to do a lot of things. Like even now, to check a network connection, we go to Google and search something to make sure the internet is working. So that's the main thing search engines are used. The other main thing is finding the information became very complicated. So let's consider. Okay, I'll give two examples. First one is let's say we have an email application, and we are sending emails daily to multiple persons, and you need to find the email which you have sent to a customer or someone a year back or 2 years back. And consider this: you don't have a search bar in that application or a search in that application. So how long do you think it takes for you to locate that email? So you have to go 10 emails per page, and let's say you have 50,000 emails or 1 lakh emails in a year. You have to go through one by one manually. But if you have a search bar and if you know some keywords of this email, you just type it, you will get it in seconds or milliseconds, right? So that's where search became more popular in recent years. Before 2004, there is no much search available. But after 2004, after Google came out with a lot of algorithms and a lot of things, search became very popular. And without search, there is no application that's coming out of things. So as you can see, there are some examples like Google, Amazon, Gmail. These are extensively users search on a daily basis. So let's try to get into a search engine. What happens really? So let's say you have a search bar, or let's assume Google. It only has a text box, right? So when you type something, FX College or something, what really happens in that at that particular time? So search doesn't have a database. We don't use database. Database will be very slower if you consider for search. Search uses something called inverted index or index. We call it as index or inverted index, which is generated by a series of processes. I will go through those things in a minute. So the search UI will just query the inverted index, which will return back the relevant search results or search results. But that's so simple, right? You have an index or a database, you just query the index and get the information. That seems to be very simple. But generating that inverted index is the complex part of the whole search engine. So the inverted index that needs to be processed before we try to query something or search something. So that's the main complex part of it. So for that, we have something called a crawler, parser, and indexer. These three major components will take care of the pre-processing. And the search UI will just make a search. So every search engine, whenever we say a search engine, everything goes through these processes. Without these processes, we cannot generate a inverted index. Right? So the first thing is we will see each one of these processes in a detailed way. Also, we will see how we can generate an inverted index and how it can be queried in the same inverted index. The first thing is called a spider or a crawler bot. We call it. There is multiple names for it, but everything does the same job. It has a set of URLs. It can be a web URL. It can be a file system URL. It can be anything. It starts from the URL and it basically crawls, takes the link from. Let's consider a web crawler. So it gets the first URL. It extracts the links and content of the URL, and it goes to the next URL and start indexing the next web page. It is typically starts with a set of URLs and keep going on until there is no URLs in the URL list. So I think this diagram can explain it better. So let's say we have a URL. First, it goes to the web crawler. So what it does is it just sends a HTTP request to the web server, and the web server will respond with the HTML file, as we all see in the web browser. The same thing which will be sent back to us. So from that HTML file, the crawler will extract all the HTTP links or URLs, whichever are available in that HTML file, and add it to a URL list. Adds all the URL to a URL list and sends the content back to the parser. That's the next part of the search engine. So the spider is nothing but a crawler that just extracts the links from a page and then extract the content from it. It doesn't do anything else. Just often go to all the links available, get the content, and move on. That's all the crawler will do. So the next thing is the parser. Parser is a process of analyzing the content and making the unstructured data into a structure. Whenever you see a web page, right? So you go to browser and search for go to FX College and go to view source or a source of the HTML page. You'll see some HTML code. You'll see a lot of JavaScript code, and which will be inside that. But it doesn't make. We cannot do anything with that code, right? So if you search in that page, you will receive a lot of JavaScript or HTML codes, not the proper search result. So the parser will take the unstructured data and extract it into a structured one. So what it does is, let's say you have a web page, we will extract the title and we will extract the content of it. We will remove all the HTML tags, JavaScript tags, and all the everything else. And we also extract the metadata from the parser. So meta keywords, meta descriptions, the last modified date. There will be a lot more data from the metadata, which will be received and store it in a database or somewhere, so that the indexer can then process it. So the other thing is, it not only indexes the HTML file, it will also parses the PDF, Word. There are almost 30 to 40 content types that parser can support. Okay. So once the parser stores something in a database and then feeds to the indexer, that's where the indexing happens. Indexing is a process of creating an inverted index, and that the document be parsed. As I explained earlier, the purpose of storing an inverted index is to optimize the speed and performance, so that a search engine can find the documents very easily. So, for example, let's say we have 100,000 documents. Okay? If we store it in an inverted index, it can be searched in milliseconds. If you scan it when someone types a query, it takes hours to scan the 100,000 documents and return the search results. Right? So that's the main use of indexer or indexing. So it's just for the speed and optimization of index. Okay, so what actually we talked a lot about indexing, indexer. What is it actually? So this is how we generate an inverted index in very simple way of extracting. This is a very basic process of creating an inverted index, but this is how every search engine creates an inverted index. So let's consider we have three documents. Documents in sense, this is after a crawler crawled the document and the parser made the unstructured data into a structured one. That's when the inverted index starts, right? So let's say we have a document called the bright blue butterfly hangs on the breeze. That's document number 1. So the first step of the indexing engine is to convert the document into a lowercase one, because search engine doesn't need, or we don't need case sensitive searches in search engine. So first thing we do is to convert it into a lowercase character. So that's the first step. The second one is there will be a lot of stop words list, which means there are common English words that the indexer we don't search those words around every from these are common English words. We have around 250 common English words that will be removed from the document. Once it is removed, then it will be created, it will be splitted by a white space. Like this bright blue butterfly hands breeze will become like this a term. We call it as a term. Each and every word will become a term. And what it does is it just creates an ID and a document ID. This is the ID. It will be an auto-generated number, and the document ID is where the term is present, which document the term is present. So, so the blue is present in 1 and 3. The document 1 has blue, and document 3 has blue, and bright has the same way. So if it is a new term, it will create a new term ID and term in it and add the document ID. If the term is already existed, it will just update the document ID there and just leave it alone. So if you see, even if you have billions of data, the term and document will be very small. Since there will be a lot of repeated terms, and mostly, let's say we have a billion terms, if you see the index, it will be very small. You don't have to store the entire document, right? Just the IDs as a numbers. It will be easy to map afterwards. So that's how we generate an inverted index. The next thing is to search on an inverted index. Right? So we generated this inverted index. So we have the index ready with the same data sets. So when a user enters a keyword, how does it work? So let's consider a user searches for query blue sky. So the same way we do while indexing, the first thing we do is to change it to a lowercase. The same way we will change the query to a lowercase one. So it becomes blue and sky with the lowercase letters. And then it goes to the inverted index and search for the term. It doesn't need to search for the entire both the terms. It will search for term by term. It doesn't search both the term at the same time. It will search word by word or term by term. So it will be let's consider the first term as A and second as B. The first term is blue and the second term is sky. So this is blue, which is 1 and 3, which has the document ID 1 and 3, and the sky has 2 and 3. Okay, so it will extract these two, and then it uses basic set theory that we learned in our schools, right? It uses most of the search engine uses AND search. which will be both the terms should be present in the inverted index, which means it uses the set theory of intersection, which will be A intersection B, which will be the document 3. So it will return the document 3, which has under blue sky in the bright sunlight one, search. So that's the document it will return, which has blue and sky. The first document has a blue, but it doesn't return that because it doesn't have the term sky. So this is how the search engine searches on an inverted index and returns the basic things. Some search engines will also use R search. In Google, you can use both. Blue and sky will return. If you use the and keyword itself, it will do it as and search. It will, if you use R as a keyword, it will use a R search. So if it is a R search, either one is present, right? So we use a union keyword for that. So if it is a union B, it will be 1, 2, and 3. All the 3 documents will be present. So this is a very basic example or example for how inverted index works, or how you can query on an inverted index. Okay. Any questions or any suggestions?
Sir, sorry for the interruption, sir. I'm having a little bit query. Suppose in the database we are having huge amount of information, right?
Yes.
So for all the information, it will be an index. Yes.
Yes. So you.
Okay, sir.
Yeah. Go ahead.
Sir, if whether a not operation is it possible, and or you told not is possible?
Yes, not is present. Not can also be done, but it will be some search engines support not, some doesn't. It's based on how we create this inverted index and how we support it. These are not actually, these are done by any companies or any program. We have to write it on our own. If we need to support, we can do it, but it's based on the algorithm or based on how you use it.
Okay,
it's basically a framework, or this is just a theory. We can develop the inverted index on our own. There are libraries currently which they can use that we can use to generate this inverted index.
Okay, sir. Sir, whether this can be done with the web mining task, because the web mining we are applying some algorithm. So here in the search engine also, obviously they will apply some algorithm. So can you suggest some sort of algorithm which we can able to retrieve the document in the same pattern?
Retrieving documents, okay. I'll just come. Retrieving is the same way you can use it. If it is stored in an inverted index, it can be retrieved the same. We have libraries called the Lucene Elasticsearch to do that. You don't have to create an inverted index; they will create it for you, and you can index it and extract it the same way. It will be simple. It will be Java based, but it will be a simple libraries that you can use.
Okay, sir. Okay, sir. Thank you, sir.
Okay, so once we have finished searching on it, the next important thing is the search result, right? So we have documents now. We have a lot of documents. How will we present it to the user? We need to know which one needs to be displayed at first. Which is more relevant, which one we need to display at second, which one we need to display at third, because we need to know which document is displayed first, second, and then, the ranking of the search results, right? So that's where another algorithms comes in. There are a lot more algorithms for relevance ranking and ordering the search results. The most common used are BM25 and TF-IDF. These are very complicated algorithms. I don't want to explain the algorithm, so I'm just stating the name. If you can search in Google, it will give you the algorithms and how it is used. Sorry. We use an algorithm in Searchblox. We use an algorithm called BM25. We use both TF-IDF and BM25. Google uses an algorithm called PageRank. That's how they invented Google itself, right? So Larry Page and Sergey Brin, their PhD paper was about Google PageRank. That's when they implemented this search ranking algorithm to rank the search pages, which then became Google. So that's the main part of search results are these algorithms to display the relevance. So when you are searching something, and if you didn't find the information in the first result, you won't feel good, right? So we are searching for FX College in Google. It should we expect the first result to be FX College, not on the third result or on the third page. So that's one of the most important thing of a search engine is the ranking. So these algorithms can be used mainly for ranking the search pages and a lot more how it has been displayed. So the next thing is the UI. When after you make searches and the search has been ranked, you need the user to inform the user this is what the search result is, and this is the information you display in the site should give more information to the user so that he can understand this is what the real search result. This is what I searched for. So, for example, if you see here, I searched for FX College. That's the same call. The first result was your college website. So this is what we call it as a statistics bar, which will show the information how many research results are there for FX College, right? So in previous slide we talked about relevance, correct? So here we have around a lot of search pages, but the first result was the Engineering College of Francis Xavier, right? So we have this many number of search results, but it was displaying our college as the first one. So that's what the search. That's why search ranking is more important. So this is the URL of a web page or a page or a website, and the page title. And this is the snippet, which is another most important thing of a search engine. So you're searching for something, and you need to know that the keyword is in this website and this content, so that you can go and look for it. Other important things usually search engine will have is the filters. You can filter by certain things, like in Google you can filter by videos, maps, images, and other things. If you consider it's called Amazon, it has filters by departments or product IDs, something like that. So that's how that's the whole about search engine. So almost we came to from end to end about how we create a search engine, like how we crawl a website, how we parse it, how we index it, and how we search it. So that's the basic about a search engine. The next important thing about search is AI. Before a few years back, around 4 to 5 years back, there is no, is there any other questions there? Anyone has any questions? Sorry, before we move to AI. Okay, fine. If you have any questions, you can ask, or else we can have it in the end. So the next important thing of search is the AI. Okay, there is some noise. Okay, sorry. Fine. So a few years back, Google introduced a lot of things in AI. They researched a lot of things, and they created a lot of AI things, which helped us to identify what we can do with search, how we can improve search and search results. So we are going to see three things in AI. and we will have 3 demos for the same AI. The first thing is predictive search queries. So if you go to Google and type something, you will presented with you will be presented with auto completion. It will predict the next word that you are trying to type. So that's what predictive search query is. It's not just based on something. It will most probably will guess what you are trying to type. That's the first real thing in AI. The next one is the AI question and answer engine, where you ask a question to search engine and which we can expect some results. That was a major breakthrough in search engines. Like it took a lot of time and effort for us to implement it, but at the end it was very promising to see how it was working. So whenever you ask something to your search engine and it gives you an answer, you don't have to go to any web page or anywhere to see the search result. It's fascinating. Like that's the second one. The third one is a chatbot. Like nowadays we don't we use a lot of things like Siri, Google, sorry, Alexa. These things, when you speak or type something, it will present you back with certain answers or questions, right? So how does it happen in the back end? A search engine will does work for you. Whenever you ask something, these questions are analyzed, and they have already created a model for it. So it will automatically query the model and just gives back you the answer. Okay, so let's see these things in a detailed or detailed. Okay, as I said, the first one is the predictive search result. So it is basically, as I said, it's basically a drop down of auto suggestion, which is based on the product database or user browse history. So whenever you query something, every search engine will store the data, whatever you query. So it's and then uses that data to analyze and present you back the present you the data. Sorry, present you the search. So let's try. I'll just give you a small demo about WHO. So this is this uses Searchblox for here we implemented a predictive analysis for auto completion, and so let's say I'm typing. So I type to COR, but it has coronavirus. It also comes back with this spinal cord injury. So if you see Google, what it does is it matches word by word. It doesn't give you suggestion based on if there is a word in the middle, it won't give you suggestion that way. Here, what happens is whatever which is very relevant to this this website or this company, it will be presented. If it is currently the most common thing people searches in WHO is the coronavirus. So we have around 1 billion searches for a month for coronavirus in this website. So, and if you search for so whatever you type, we will have some information which is more relevant than just whatever it's not from the title or something. This is generated by an AI engine which is more relevant for this website. That's the that's about this predictive analysis of search. So when you make a search, it just gives you back the search result, and it also have all this information about various countries and various things. That's the first part of AI search. The next important thing is answers. So we usually go to Google and search for what is my IP or who is the president of USA. These things, when you go back a few years back, they won't. These search results won't be. You won't receive the information in Google itself. It redirects to some other website. There you can go and see the information. After a few years of analysis, they started using this AI engines, which will generate all these questions and answers to inform the customer that this is what it is. So if you ask a question to a search engine, it will present you back with the answer. So let's see that how it works in a real time. Okay, so this is a company where we implemented AI answers. This has a lot of products and information about the product. So users comes here and search for so the user comes and searches for some whatever it is, how to use Arlo rechargeable battery. The answer will be presented here, and it will give you a context of the answer, and then it redirects back to a URL that you can go there and search for, read more about the information if needed. So whatever question you ask to the search, it will just present you the exact answer of it and gives you some query context and then a URL that you can go and search. So that's instead of the user can just see this. Okay, so you can use the power adapter to use it, or else if he wants to see a detailed version of the answer, he can go to the URL and read about it. So this is one of the major things. Whatever you ask, this will give you answer about it. So if you see whatever questions you ask, it will give you an answer of it. Also, this questions are generated by the predictive analysis, which will also use AI to detect the questions. So that's the most AI answer is the most important thing of the currently search engines. Any questions in this? The next most important thing is chatbots. As I mentioned earlier, chatbots are like known as conversational agent. It is provided by AI engine to interact with chat. So if you want to let's say you have a product company or some company where customer will come back with service queries, you need to deploy hundreds of agents to answer those search queries. Right? Instead of that, you can use a AI search engine or AI search engine which will replace to the customers with all your questions, whatever questions you ask. So, so there is a pandemic going on, like coronavirus. So, what happened was a lot of research happening over it all over the world. A lot of journalists, people provided a lot of papers, published a lot of papers, provided a lot of information. Everything has been open sourced, and we indexed and created a chatbot that helps people to understand what is about coronavirus and COVID. So this is one of the search. You can search all the. There was around 50,000 articles, or not articles. It's published journal articles that we indexed and we can search on it. So we also have a chatbot that answers about the questions. So let's see how it works. So. So I typed that spelling wrong as COVID, But if you see, it uses the spell suggestion which search engine uses, and it corrects on itself and then creates, gives you the answer. So if you want to know about the article, it will just present you back with the article of the abstract of this article. So whatever you type, it will respond back, and it will give you a content of it to search for it. So let's see, do we have your... Okay, so yeah, FQR seems to be a distant prospect. So as we all know, even it does know things, it seems. So it gives you information about this article, and it also gives it extracts the text from that article and gives exact results for it. So we will again ask with the exact same thing. So do we have code? Okay. For now, there is no cure. Yes. Even the same thing. If you whatever questions you have, it will just gives you answer that. Give you answer for the questions. It's just a conversational thing, but it uses search engine to answer your questions properly. Any questions on it? So that's mostly the end of the 3 AI searches. The last thing I wanted to show is to create a search engine for the website and see how we'll try to put together everything what we have seen from first crawling, indexing to search UI. Just try to log into my server and see. So I'm just not going to give more demo on this software, but because this is about the company, so we'll just have a demo about the college. So as I said, Searchblox supports a lot of data connectors, right? So these are the part of data connectors. The engineering college, this is a website, so we are going to use HTTP connection. So first thing, as we saw in the slides, the first thing the crawler needs a URL, right? So we will present it with the URL, and these are default settings, so we don't have to worry about those things. And we will start indexing. So what currently happening is it crawls the website, it parses it, it creates the inverted index, and the information is available for us to search. It currently indexed 23 pages, so it keeps indexing until it finds everything is indexed. So let's wait for a few minutes until it became 50 or 55. So something. Okay, so now we can search for something from the website. Okay, so as you see, we have these keywords which is present from the web pages, and these are the search results that your college has. Um, whatever you search, it will be available through the web pages. So I'm not sure what to search. So, so we have a lot of search results, and you can see how it's works. There are departments. It's still indexing, so there will be a lot of pages which will be missing. It's keep indexing. So once it is fully indexed, you will have all the pages and you can search properly on the same. It's actually very simple to create a search engine for a website or make it from there. Think that's all from my side. Any questions, any suggestions, any doubts can be answered.
Dear participants, if you have any questions or queries, you can post it in the chat box or you can unmute and ask the question to the speaker.
Okay, so let's some questions. Okay, building a search engine for a project. Okay. So it depends if you are going to use AI or you just building a search engine. It's the best one will be Java. But if you are going to use AI or some other tools, the best thing would be Python. It depends on the project you are planning to use. Pros and cons of a Searchblox search engine. Okay. Pros, there are a lot I can talk about, but cons. Okay, pros like we have around 150 data sources. As I saw, we just indexed, we just created a search engine for your college website in a few seconds, right? So, and the same way you can index Dropbox. We have 150 data sources. You can index database. You can index lots and lots of things that you can do and mix it. Cons that the search engine uses Java. The problem is when you have a large number of data, we sometimes some users have millions and billions of data. The inverted index become very large. It will be around a few TBs of data. So handling those will require a lot of memory. So you need to use a cluster based search, and it will be little on the expensive side of infrastructure. That's one main drawback of. It's not a drawback of Searchblox, but it's a drawback of Java itself. Sorry. Can you say a short info about Chatbot? Okay. I'm not sure what algorithm or information about Chatbot. Basically, Chatbot is a conversational bot. How it happens is after indexing, we won't create this for Chatbot. We won't create the inverted index. Rather, we create a model for a AI. The model it's for Chatbot. We will create a model, not the inverted index. So the model will be used for the chatbot, the UI, whatever you saw, whenever you type something, it goes to the model and then it get the response from that model, not from the inverted index itself. That's one difference between AI and chatbot and search. Which algorithm is used for chatbot? There is no algorithms in chatbot. We use a AI model to design it. It's the artificial intelligence model that we use to create and show the information. Which language is better for analysis? I'm not sure which analysis you are asking about, but it's okay, Python. It depends on the data that you're going to analysis. If you have a large number of data, Python is more. The Python is more. You can do a lot with Python, but with R, it's more of a business intelligence tool than processing analysis tool. So it depends on your use case as well. Okay, Python is easy to learn. There is nothing like. It depends on your mindset. You can learn anything. It's up to you. Any other questions? Okay, so
I hope you have answered all the questions from the participants.
I think so, ma'am.
Yes, sir. Yes, sir. Thank you for the wonderful session and the live demo of Search Engine Search. The session was very useful, and the information that you gave so far has not reached us through any webinar earlier. So we are thankful to you for giving a good insight and giving a good expertise ideas on search engine design. Thank you so much for joining us and accepting our invitation and having giving your information here as a speaker. We are very thankful to you, sir, for sharing information from your side. I thank on behalf of Department of Information Technology and Management of Francis Xavier Engineering College. I post my thanks to you, sir, for having given a good information on the topic which is given to you, sir. Thank you so much. And my sincere thanks to Mrs. Agnes Joshi and Mr. Hannah for having arranged and coordinating the session in a wonderful manner. Thank you so much. And finally, my thanks to all the participants who have joined us for the session. Thank you all. Join us for the upcoming webinar in this week. Thank you, sir. Thank you.
Thank you. Thank you.
Yeah.
Thanks, everyone.
Thank you all. Thank you. Dear participants,